Good morning and welcome to our Emerging Tech Fest. Good morning. Bore da and croeso. My name is Carole Eccles and I'm part of the CPE Centre for Photonics Expertise team. And this morning we are going to be asking you to join us under the theme of working with academia. Today, we're going to be taking a look at how CPE, the Centre for Photonics Expertise, supports R&D and product and process development. And we'll be hearing about how recent developments in technology can boost productivity and innovation in Wales. We'll be showing you some actual case studies to give you an insight about what's actually going on in academia that is really close to the market, and telling you much more about how CPE can help boost your business. So before we begin, we know this is live streaming, but you can interact with us by typing questions and comments in the Q&A box on the right of your screen. And we really want to have those comments. We've put some time aside at the end of our session to answer those. So look forward to hearing from you. So I'm going to hand over to my colleague now, Dr. Hazel Hung. Hazel has 10 years experience working in the photonics industry. She's worked in R&D, product development and project management. And throughout her career, Hazel has maintained really strong university industry relations. So without further ado, I'll hand over to Hazel.
Thank you very much, Carole. Thanks for the introduction. I'm just going to try and share my screen now to start the presentation. Is it working now, Carole? Can you see the first slide?
It is, Hazel.
Thank you. Right. So yes, I'm here today to explain to you what the Centre for Photonics Expertise is and what we are doing as a team to boost industry in Wales. I'm also joined today by my colleagues, Dr. David Coathup, Dr. Yasir Joya, Dr. John Tomes and Dr. Hatef Dinparasti Saleh, who are all here today to tell you about some of our facilities, as well as showcasing some of the projects that they've been working on in collaboration with industry. In the first half of the talk, I'll be presenting the overall picture of what CPE is before handing over to my colleagues in the second half. So CPE is a Pan-Wales programme. We're funded by the European Regional Development Fund through the Welsh Government to support university industry collaboration. We consist of 4 university partners. Wrexham-Glyndwr University are the lead partner, and they are based at the Optical Centre in St Hatef. I've got a lovely picture of the building here on the left. And then we also have Aberystwyth University, Bangor University and the University of South Wales. And the aim of the programme is to boost business growth in Wales by supporting product and process development. So a company would come to us with a particular engineering challenge, say in production or quality control, or maybe they're looking to design a new product. And we would tackle this engineering challenge based on our knowledge of photonics technologies, together with the company's knowledge of their systems, their business and their sector. So here's a little background information about us. CPE was launched in April 2019, and we've worked with 40 companies since then on projects focusing on their products and processes. And this is on over 50 different R&D projects. And we've also had 9 enterprises engaged in multiple collaborations with us as well. And these projects are very much company focused, and it's also about developing a collaborative working relationship between industry and academia that might lead to longer term collaborations through grant funding applications beyond CPE that then lead to innovation in industry. And 3 of the projects have actually led to 3 funded PhD studentships. A few grants have been applied for to the total value of 540k, with more grant applications on the horizon as well. And actually, I just heard this weekend that one of our industry collaborators has been successful in achieving £30,000 funding for a feasibility grant. And this will work alongside the CPE project, which will then feed into a bigger £250,000 grant application later this year. This value here, £280,000, is pledged in-kind investment in R&D. This is staff in-kind costs by our industrial collaborators. So every CPE project requires matched in-kind contribution in staff costs to the project. So just to give you an idea of the size of the projects, then the average value of staff costs on the project is about £5,000 to £6,000. So there's no actual cash cost involved. This is evidenced by timesheets in staff costs. And the major investment for CPE was the installation of a brand new £1.2 million thin film coating facility at the Optics Centre. And David Coathup will tell you more about that later on. And this slide here is just to give you an idea of some of the companies that we are working with. These are companies based across Wales within the West Wales and the Valleys region, and I will show you a map about that on that later. And it's just to show you that we work with a variety of sectors. We work with companies from the scientific and medical sector, lighting, agriculture, also photonics companies as well. We've got Optical there. Welsh Slate is a slate manufacturer. We've got packaging with Transcend Packaging. Shawchill, a refrigeration company. Diamond Centre Wales is in the jewellery sector. So a really broad range of sectors. So let's talk about photonics then. What is photonics? Photonics is a light-based technology that involves the generation, detection, and the manipulation of light. So the generation of light would be through lasers, LEDs, light bulb screens, and the detection of light could be through cameras, sensors, and solar cells. A good example of manipulation of light is through telecoms, so your phone and internet signals through fibre optic cables. So photonics is prevalent in our everyday lives. Most of us have a smartphone, which is packed full of photonics technologies. It's got a screen, cameras. The modern ones now have multiple cameras on, infrared sensors. And just think how far mobile phone technology has come in the last 10, 20 years. 20 years ago, I owned one of those brick phones that made phone calls, and it sent text messages. I got my first smartphone in 2012 with a camera that took blurry images. And in fact, I bought my very first digital SLR camera that same year. And I've barely used that camera in the last 5 years because the pictures on my smartphone are just as good, if not better, with the image stabilization. And then there are, of course, huge advances in our internet technology. We have fast internet connections through all our internet signals carried through fibre optic cables. So there's been this explosion of photonics technologies in the last 20 years, coupled with advances in other emerging tech like AI, big data, 5G, microelectronics, and components like cameras, sensors, LEDs, single board computers. They're all smaller, cheaper than they have ever been. And combining that with things like 3D printing technology, maybe the Internet of Things technology as well, all this tech is so accessible that now we can put together just a base level prototype or desktop demonstrator within a matter of weeks. Laser materials processing technology also has come a long way. 3D printing technology is a great example of that. Laser cutting as well is a long established technology using CO2 lasers to cut metals. But there's been this shift to fiber lasers in the last decade, as well as pulsed lasers, which means it's possible to cut or engrave anything from a piece of fruit to titanium. And just to give you an idea of the size of the photonics industry, according to the latest figures from the Photonics Leadership Group in 2019, the UK photonics output was £13.5 billion, which is equivalent to the UK pharmaceutical, the fintech, or the space industries in the UK. So this is a sizable industry, and these figures are just for the photonics industry. So they are for semiconductor manufacturers like IQE, laser manufacturers, fiber optics, and the products of the photonics industry support a wide range of industries like manufacturing. life sciences, food industry. So our focus at CPE is not in the photonics industry, although we do support photonics companies as well. But our focus is in using photonics technologies applied across all industries. And this would be through photonics solutions like sensing and measurement, vision systems, laser processing and spectroscopy. So just to tell you about our expertise then within CPE, each of the university partners at CPE specialises in their own area of photonics. So we do cover quite a broad range of photonics technology. Our Bangor University team are experts in laser processing, so laser cutting, welding, texturing, engraving, and laser processing is quite commonplace in manufacturing these days and a well-established industry. But there's such a wide variety of systems available, and if you're processing an unusual material, then this is where perhaps a little R&D may help to find a suitable recipe that will cut or engrave your material without causing visible damage to the product. So Bangor University are working with a company called Diamond Centre Wales on micro-engraving diamonds for tracing and security purposes. And Yasir will tell you more about that project later on. Also, there's optical design and prototyping. So optical modelling, for example, in imaging systems or in lighting design. For prototyping, we have some in-house prototype facilities at the University of South Wales, such as 3D printers, CNC machines, that companies would have access to. Hatef has got a great case study later on, and John's case study as well is related to optical design. We've also have, I've mentioned before, the state-of-the-art optical coating facility at the Optic Centre, which was installed during lockdown and has been fully operational since the end of last year. And this facility is unique to the UK for R&D of thin films, thin film coatings, very much like the coatings on your glasses, but perhaps we'll be looking at more specialised coating applications, and David will be able to tell you more about that later on. We've also worked on a few projects involving imaging systems for both the visible and thermal imaging. The example shown here is for a collaboration with Aberystwyth University and Churchill. So Churchill specialised in refrigeration, and they've got their own patented technology which allows you to keep items refrigerated in areas where there'd be a poor connection to a power grid. So this would be for cooling purposes in the medical sector, say for vaccinations or blood, or in the beverage industry where you just want to keep your drinks at nice cool 4 degrees. So this is what this thermal image is showing here. We've got bottles in the fridge, and part of the project was to monitor the fridges and identify which areas could improve the performance of the fridge itself. Bangor University have also worked on a project involving visible imaging system for an automated product counting with a company called Welsh Slate. At Aberystwyth University, they also specialise in chemical spectroscopic analysis, as well as other aspects of chemistry. So this image here is of a healing balm, which is based on a 200-year-old recipe containing clay minerals. This company is called Mon Naturals, and they want to get medical approval for their product so that it can be available on the NHS for wound treatment. So part of the process is to ensure that it's safe for long-term use, is to be able to look at the size of the slate particles, because if they are absorbed into the body, then this could potentially be harmful and cause long-term effects. And also they want to understand the analysis of the chemical composition of these particles as well. And at Aberystwyth University, they have specialist equipment to carry out a particle size analysis and a spectroscopic analysis for the chemical composition. And this is something that Mon Naturals simply wouldn't have access to without this kind of collaboration. And finally, we're working on quite a few projects involving sensors and measurement, and types of light-based sensors range from a barcode scanner, maybe distance measurements like with a laser ranger. But we're working on more new innovations like for analysis of chemicals and liquids for the environmental sector. So let's have a look at which industries CPE has supported. The majority of companies that we work with are manufacturers. Others provide services like test and measurement services or consultancy, and we work with a number of startup companies as well. And if you look at what sectors all these companies are in, then between 25 and 30% of them are in the photonics sector, and the rest are in other sectors. So you can see that the majority of companies we work with are indeed outside the photonics sector, and are in other industry sectors like scientific and medical sector, environmental, fashion and jewelry, and sensing and measurement, and so on. So what's in a CPE collaboration? So first of all, how does a company know if photonics is relevant to them? Because it's not something that people can relate to as easily as the terms engineering or science. Quite often we might actually say to a company, don't dwell on the photonics aspect. Instead ask yourself this question: is there an engineering challenge within my organization, like a bottleneck in production or in quality control, or perhaps there's an issue in a design for a new prototype? And if the answer is yes, then there might be a solution that we can come up with within the CPE team. Usually the BDM team, so myself or Carole, would discuss these potential issues with the company, and then we take them back to the team to see if they can brainstorm any ideas. So this is where the academic team tries to see how they would approach the problem using their expertise in photonics technologies. So I've got a word cloud here with the types of photonics technologies that have been used on CPE projects. So the most common is in laser processing. Also high up on the list is visible or thermal vision systems, sensors, optical design, and then the company brings in their contribution. And this is really important because the company knows the industry they're working on, they know the market drivers, and they maybe have years of engineering knowledge as well to add to that. And we combine all this together in a matched collaboration. So CPE projects are about combining the company's knowledge of their business with our knowledge within CPE of photonics-based solutions. And that feeds into this hive of ideas through collaboration and innovation, leading to development of products and processes that support ultimately business growth. And if we look at the type of R&D projects that we've been working on, the most common project areas are in prototype development, feasibility studies, process development, test and analysis, also quality control development as well. And this doesn't always involve cutting edge research. So sometimes it can be a case of finding a market solution that will work, or maybe work with a bit of modification. And ultimately the goal of the CPE project is to support business growth. And this will be through maybe cost savings or improved yield. Perhaps the project opens the company up to a new market. And in some cases, we've had companies applying for further grant funding, as I've mentioned before. So we've had 3 applications submitted so far. 2 have been successful, and we're still waiting to hear the outcome of the 3rd. And there's more on the horizon as well. And another growth outcome is new jobs. Our CPE projects have created 3 PhD studentships, and these are KES studentships where the student works both at the company and in the university as well. And they're working to further strengthening, which further strengthens that university industry collaborative bond. And actually a lot of the companies we work with haven't worked with academia before. So typically if you want to set up a university industry collaboration, you need to apply for grant funding together, and that's a lot of planning, there's lots of paperwork, and it takes time. But with CPE, we can get a project up and running within a few weeks from the first introductory meeting. And during this time, there would be back and forth meetings and emails to discuss the plan, to discuss and plan the project before a project plan and project agreement is signed off. And projects are, just to give you an idea, they're typically sort of 3 to 6 months in duration. They can be longer. There's not really a hard stop to it. And on average, they cost £5,000 to £6,000 in staff costs. So these are relatively short projects, but there isn't a limit to the number of times that we can work with a company. As I've mentioned before, we've got 9 companies working with us on multiple projects at the minute. So, you know, one project can lead to another, or some can run in parallel if you're working on different processes. And we'll have some case studies then later on to put this all into context. So what about the eligibility criteria? So first of all, to qualify, businesses must have an address within the West Wales and the Valleys region to show impact to the area. So West Wales and the Valleys is shown by this map here in the dark pink regions. So there needs to be a registered address or business address within this area. We also work with registered companies of any size, from single entrepreneur, SMEs, large enterprises as well. The projects have to impact business growth and development. We don't want there to be any risk to job displacement. The last thing we want to do is take business away from anyone. And finally, number 5, projects are based on matched collaborative effort. So there's no cash cost to the company, but companies have to provide match cost in staff time, which is just evidenced by timesheets. But even if a company doesn't necessarily fit into all this criteria, we'd still love to hear from them and have a chat. There may be other ways we can help if it's not through CPE, because we do have a strong network that we might be able to help you with. So now I'm going to hand over to my colleague, Dr. David Coathup, who will tell you all about our brand new coating facility. And then after that, there'll be some case studies.
Thank you very much, Hazel. Good morning, everyone. My name is Dr. David Coathup, and I'm here today to speak to you about the CPE's new optical thin film research facility. My aim today is to tell you about our skills, activities, and capabilities, and how we are going about using them to improve the products and processes within Wales. And in doing so, I hope I can inspire some of you into working with us. Next slide, please. So before I dig in, let me give you a quick run through of what a thin film coating actually is. A thin film coating is a small layer of material placed on an object, tool, or product to radically change how it interacts with the world around it. For example, the plain metal of a car is dull and vulnerable to rust, but a thin layer of paint can make it eye-catching and resistive to the elements. Likewise, a small piece of glass is highly transparent, but a thin layer of metal, like aluminium or silver, can make it highly reflective. Thin films have found their ways into most modern applications. They're an essential part in electronics, including the laptops on your desks and the smartphones in your pockets, as well as green technology, where they form a predominant part of solar cells and photovoltaics. As they are used in optical components, they play a huge role in defense and security, as well as our manufacturing areas such as aerospace and automotive. And in addition to other optical monitoring systems, they're widely involved in agriculture and environmental. For a company, adopting thin film technology can be an essential step in developing a world-leading product or process. And it's helping Welsh businesses to develop these products and processes. That is our aim. Next slide, please, Hazel. So, our new coating research facility. Our coating research facility is a part of a £1.2 million investment by the CPE in bringing thin film technology to Wales. A good example of our work so far has been with Coathup, located here in St. Asaph. Coathup are one of the world leaders in civil and defence optical technology, from cameras, night vision, heads-up displays, head-mounted displays. Coathup are one of the world leaders in these applications, and it's our work with them that have helped them maintain this lead. And I'm hoping that after this presentation, I can contact some of you listening in and help you develop your own products. Next slide, Hazel, please. So let me begin by discussing our capital equipment. Our key capital purchase is our labelled optics Series Pro 1350 optical coater. The Series Pro is a current industrial benchmark for high throughput industrial standard coatings. Our machine is the only machine of its kind in Wales that's currently available for research. The chamber is 135 centimetres wide, allowing it to hold lots of samples for mass production. It has 2 electron guns for evaporating most dielectric and optical materials, as well as 1 thermal source for metals. It also contains a plasma source, which is essential in improving the quality and density of the thin films. As this machine is the current industrial standard, the products and processes developed within it will be ready to transfer to market. Next slide, Hazel. Another of our key capital purchases is our Agent Carry 600 spectrophotometer. The spectrophotometer's role is in qualifying the performance of the thin films deposited within the chamber. It does this by measuring the transmission, reflection, and absorption of the optical coatings over a wide range of wavelengths, from the far UVC to the far infrared. Due to the current coronavirus pandemic, we've seen a lot of interest in UVC applications due to UVC's ability to disinfect surfaces. Whilst this machine's primary role is in supporting the coating chamber, we are open to collaborative projects where we use it to investigate the optical properties of samples developed elsewhere. Next slide, Hazel. Our last key capital purchase is our environmental chamber, developed by James Technical Services down in South Wales. The role of the environmental chamber is to test the environmental stability of the optical thin films deposited within the chamber. It does this by simulating high temperatures from -70 to over 150 Celsius and at a wide range of relative humidities from 0 to 98%. Like the spectrophotometer, this plant is available for collaborative use without involved in the coating plant. And as environmental testing is an essential part for most products, I expect there to be a wide range of applications for this machine. If you want to know anything about these machines, please don't hesitate to drop your questions in the comment box below, and I'll be happy to answer any questions. And with that being said, I'd like to pass you on to my colleague, Dr. Yasir Joya, who's going to speak to you about our case study with Diamond Centre Wales. Thank you.
Thank you, David. Good morning. My name is Yasir Joya. I joined CPE as a research officer in laser microprocessing and currently based at Bangor University. So at Bangor University, we have in-house facilities for laser microprocessing, nanofabrication. We use lasers for machining, for cleaning, polishing, texturing, welding, drilling, and marking applications. So in addition to lasers, our group, which is led by Dr. James, have developed special capability in photonic simulation and near-field optical nanoscopy by using Bangor's PCM superlens nanomaging technology. Next slide, please. So this case study is based on our recent CPE project we performed with Diamond Centre of Wales, DCW. That is our client. So DCW is based at Port Talbot, Green, South Wales, that provides a bespoke manufacture and personalization for diamonds jewelry. So DCW houses an end-to-end service for the design and manufacture of precious metal jewelry. The team is supported with the state-of-the-art digital design, prototyping suite, and R&D department, CAD, jewelry-specific software, industry-grade rendering software, laser welders, rapid prototypers, subtractive methods, and 3D scanners. So DCW has also two fully equipped workshops and teaching facility for traditional, present, and future goldsmithing techniques, for forming, melting, casting, post-production, prepping, plating, and finishing applications for the jewelry. Next slide, please. So this case study actually emerged from our successful CPE collaboration project we completed with the Diamond Centre of Wales with Bangor University. So currently, at the start of the project, our business manager visited the site, and we discussed, we had a meeting with the DCW, and they discussed that currently there was no standard practice to track and trace stolen goods during the resale, making it very difficult to recover lost or stolen high quality, high value diamonds. DCW was entrusted to provide a standardized, secure diamond identification and tracking system. The CPE team and BU are highly skilled in laser processing, particularly in the writing, micro and nanoscale features. So BU performed a feasibility study to engrave permanent micro-sized labels on the diamonds. So one of the challenge of this project was to mark the diamonds without harming the quality and optical brightness and the shine to the human eye. So during the project, we obtained very promising results, and we were successful to identify the required laser parameters for engraving and write text up to 25 micron in height, a QR code, and a combination of a series of serial numbers with a marking depth of only 200 nanometers. So DCW and Bangor University are willing to carry on or to another project, CPE project, to take this work further. And we also published one of the journal article, Materials Today communication, from this research. So overall, a really great outcome of this feasibility study, not only in the development of a new process, but also in the development of a new collaborative relationship that will go beyond the CPE program. So in total, we have 4 CPE collaborations with DCW, 2 with the Bangor University and another 2 with the Aberystwyth University. So that concludes this case study. So with this, I would like to transfer this presentation to my colleague, Dr. John Toms from Aberystwyth. And thank you very much for listening.
Hi, thank you, Dr. Joya. Hello, my name is John Toms, and I'd like to quickly take you through a case study that CPE did with Tection. Tection provides animal health and welfare management for livestock. That's primarily sheep, but also cattle, horses, alpacas, other ruminants. And they do this through a quantified and scientific approach to parasite burden. That's achieved through an automated microscope system that counts parasite eggs in samples prepared from the animal's feces. In the right-hand image of the equipment on the slide, you can see on the left is the kit that prepares the sample, and on the right, the dark triangular unit in the corner is the automated microscope. And this locates the sample, adjusts the light and focus, and then takes images, which is scent detection for automated or manual parasite egg counting. Feedback from Tection then provides the stock owner with quantitative information on if, when, and how much wormer to administer. In the next slide, please, Hazel, I'll describe how the project centered around 2 key problems. The first was to correct for a loss of dark field illumination in the microscope images. The Tection people are a lovely team to work with, really skillful at what they do. But they found that following a large group of design changes, it had left the Mark II pre-production design not performing to its optimum. And personally, I feel part of this was that they were just so close to the problems that they weren't able to do what we at CPE had to do, which was step back and start from the beginning, literally start from first principles. That approach was something that led us to model the lighting optics, which is quite a complicated situation with a series of refractions and refractive indices to find that it should indeed have been working as Tection had designed, but it wasn't. So working at the actual observations backwards, we discovered that a small manufacturing step had been removed, and that was the cause of the problem. So small, in fact, that they hadn't even mentioned it in the project briefings. And I know I've been there in the past doing designs where a fresh pair of eyes can really see the things that you were just too close to see. So once that was resolved, the second part was to investigate the current resolution limiting components of their microscope system. And what we did there was to give a series of options to improve the image resolution to support a more automated AI-powered count. and speciation of the eggs, which can identify mixed infections. And the aim of that is to provide the best possible livestock care. What we did was we generated a basic, better, and best series of options for the company to choose from. And this managed to achieve in the best performance a threefold improvement in resolution. And we also identified some potential areas for cost savings. And in the images, you can see there the higher contrast of the image on the right, which helps support some of the automated counting. I think it's really important to point out that the work we've done together has, in the short term, provided information on an existing problem, but long term, it stimulated attention to research looking into an opportunity to expand into new markets and further improve a potential new high-end instrument. That work's been supported through Aberystwyth University with a technology transfer grant, and we're working on the details of a second CPE project to provide ongoing support in their new venture. That concludes this case study, and thank you for your time. And I'd now like to hand over to Dr. Hatef Dinparasti Saleh for his case study. Hatef.
Thank you very much, John. Hello, everybody. My name is Hatef. I'm research fellow at University of South Wales for Center for Photonic Expertise. My background is in quantum photonics and aerospace engineering. Today, I'm going to present a case study of one of our first CPE projects in collaboration with Global Laser. The next slide, please. Global Laser is a designer and manufacturer of low-power laser diode modules. The company is located near Brecon Beacon National Park, and the factory covers about 9,500 square feet. Main application for their laser diodes are in machine vision, alignment, medical, scientific, and defense. They also manufacture detectors, some holders, mounts for their laser diodes. Their laser also found application in automotive sector, for example, like tire inspection, jet alignment, and visible alignment and positioning tasks, and illumination, 2D, 3D triangulation, and quality control and inspection. The next slide, please, Hazel. Motivation of this collaboration project was to see if a 3D printing technology can bring something new and help their production line, and mainly to enhance customization and prototyping capabilities in Global Laser. We all know that injection molding and injection molding in particular is not a very economical way of production for single prototypes or a small batch of quantities. But in the meantime, for the range of parts in Global Laser, selecting the optimal 3D printing technology for particular design was a big challenge. Especially, it becomes very important where you have a part where you require high accuracy of this part. This challenge in FDM 3D printing technology and SLA 3D printing, where we have a curing after printing, we have curing process after printing, becomes very important, and it's a big challenge. The company requires many small parts such as laser mounts, holders, which are designed and in-house built with a CNC machine or injection molded. And majority of part of this injection mold and CNC machine stuff was used to be provided by external supplier, which can be quite costly in particular, and especially in low volume, injection molding becomes absolutely senseless So the project with USW was a feasibility study to see if the company would benefit from investment in 3D printers, both in terms of functionality and cost for the production. The project began with a review of current 3D printing technologies to see which printing technology can really fit the requirement. Within USW, we have access to a range of equipment for prototyping, prototyping, such as CNC machine and different type of 3D printers, FDM, SLA machines, and other 3D printers as well. The point is that where we use, for example, FDM machine, where the heated nozzle deposit polymer material, considering the diameter, the nozzle, and the resolution of the printing, we found that this 3D printing technology can be quite useful and suitable for example, the holders or base of the laser diodes stuff, where there is no strict requirement for errors and accuracy stuff. In the meantime, they had also very small parts where the accuracy needed to be around 50 micron, where we have used SLA 3D printers for this type of parts. Global Laser have since purchased an FDM 3D printer where they actively use this 3D printer for their manufacturing process. And they are also, in the meantime, in the process of purchasing SLA 3D printers at the moment. The company also estimates that the cost saving of 5%, equating to approximately 8,000 pounds per year, is the benefit for the company from this 3D printing technology. So this is a significant cost saving for them. And it also makes it able to try different type of designs for and custom-made design for some customers where they really need to change slightly dimensions or the design and shape to fit customers' need. An additional outcome of this project was an application for KISS studentship, which was granted, and the engineer from Global Laser started his PhD studentship early this year. So if you have any question, I will be happy to answer to all your questions. And now I hand over to my colleague, Dr. Hazel Hung.
Thank you, Hatef. And thank you, David, Yasir, and John, too, for those presentations. I think they really demonstrate the diversity of the projects that we're working on and how those projects are helping to drive business growth with cost savings and further collaborations outside of CPE, whether it's KES studentships or grant funding to develop those products further. We will be taking questions shortly, so if you have any questions, then please do pop them on the Q&A on the right of the screen. Just before we go on to the Q&A, I just want to say that I would highly recommend you join our panel session on Thursday, where we'll be hearing from a few of our industry collaborators, including Diamond Centre Wales and Tection. Those CPE case studies are only a small part of the bigger picture. So during this panel, you'll hear their thoughts on how photonics is driving innovation in Wales and how that fits into what they're working on, as well as how they've achieved their innovation successes so far. And finally, here are the contact details for myself and Carole as well. Come and check out our virtual exhibit during this Emerging Tech Fest conference and come and say hello. Thank you. Now I'll hand back to Carole to start the Q&A.
Okay, thank you. I think some really exciting work there. And we've got some exciting questions too. Mike, what have we got in the chat?
Yep, thanks, Carole, and thanks, Hazel. We've received an awful lot of interesting and diverse questions across the board. So a big thanks to everybody who's submitted those. We'll do our absolute utmost to get through as many of those as we possibly can in the time that we've got left. So first question we've got here, we've been asked, is there a lot of sign-up paperwork or contracts, etc., to process in order to work alongside CPE?
Yeah, there isn't actually. We have very clear paperwork. It's been devised in conjunction with all 4 universities. So it's a very quick process. We produce a project scope and we have a collaboration document. So it's quite easy to set up the project and work with us. And I think, as Hazel said earlier, we can get a project up and running very, very quickly. Maybe, you know, I think the shortest I've ever done it is in 2 weeks. So.
I should add to that, Carole, as well, that part of our job is to facilitate the process and just make it as easy as possible for the company as well. So we just try and take the companies through the process as well, just to make it as smooth as possible.
That's lovely. Thank you guys for the answer and clarifying that question. Next one we have, we've been asked, if we, being the enterprise, developed a new product, would we also own the rights to it?
Yeah, I can take that question if you like, Mike. Yeah, so if you're a company that's designed a new product, if it's an existing product, say, for example, then you would obviously own any IP rights that you bring to the table. But say, for example, during the project, then you work together on something, then that would be shared ownership of the IP. But all the universities, university partners, they're very used to working with industry and you know, making it a fair sort of a deal between both parties. You know, we want to maintain good relationships with industry. Unfortunately, as it's part of the grant means that we can't just give away the IP as well. So we do have to maintain a share of it.
Okay, thanks Hazel, thanks for clarifying. Next question then is, this comes from Jonathan Sellers. He asks, what or any criteria do we use for choosing suppliers of materials that may be necessary for these collaborative projects?
I'll step in there. Or maybe John, if you want to come in on that one. No. Sorry, John, you're muted.
Yeah, I think Carole, actually you'd be better at answering that than me actually thinking about it.
Well, just quickly to say that our universities have a tender process. Universities often have preferred suppliers, but we often work outside that list if it's necessary. I think one thing that you know, if we help companies develop new products, those companies are always looking for supply chains within local areas as well. But we do follow strict WEFO and the RDF guidelines when we're tendering for any bigger items. I don't know if anybody else has anything to say on that.
Yeah, I'm obviously, we're a chemical supplier, so we're obviously, I suppose the biggest company that we deal with is DuPont, but we're a multiple distributor in the UK and Ireland, so we work quite closely with 50 or 60 universities in the UK. So I'm just trying to understand the process of how, you know, we could work with you. And equally, my second question is, we've done a lot of Innovate UK projects where we've also been part of the consortium. And I'm wondering if that's also something you consider.
Yeah, do come and see us in the virtual booth, Jonathan, and we can have a chat about that. That's really interesting. Thank you.
Okay.
Thank you, guys. And the next question, I think we may have already partly answered this, but just to clarify for everybody, it's been asked a couple of times. For companies that are not based within Wales or the West Wales and Valleys region, is there still a way we could work with CPE?
Yes, definitely. I think if you're interested in our expertise area as well, then do get in touch. If you're, you know, you can either that there are ways perhaps that you can work within CPE programme. It depends if you do have to have an address within Wales, and if that's not the case, then there may be other ways that we can work with you that would be outside of CPE, because we've got a wide network as well. So it could be that it'd be better just to work with the universities individually as well. But I think in those cases, we're sort of, myself and Carole will be quite a good sort of point of contact then to sort of distribute you then into the right direction if CP is not the right route for you. Yeah.
That's great, thank you, Hazel. And next up, we have a question which I think could well be a commonly asked question across the board, I would imagine, in the current climate. Has the current COVID-19 pandemic impacted the project significantly? And if so, please give details, especially surrounding any academic and industrial collaboration work, for instance.
I'll leap in there just to say that we've been very, very fortunate in that a lot of our projects, we've still had access to university labs. We've been able to work with our academic team remotely. And I know we've had a couple of small setbacks because of COVID, but overall we've done extremely well. I don't know whether any of our academics want to come in on this and just say how they've managed.
I think things have gone surprisingly well, really. We all seem to have been able to maintain quite a lot of progress through working from home, and most of the universities now do have lab access where necessary. So yeah, I think it hasn't really had the kind of impact that we first thought it might have, and we've managed to maintain quite a lot of the existing timetables on the projects that we've been doing. I think everybody's worked really hard to sort of overcome the problems that we've seen, and I'd thoroughly encourage everybody to continue trying to engage with us, because we seem to be finding solutions to the problems that we thought we initially might have had.
Have we got time for one more question, Mike? Or how are we doing for time?
I think we do. We've got a couple of minutes. Yeah, got a couple of minutes left. So we've got time for just one more question. We'll finish off with this one. Do we have to have an engineering research and development team, or can academic teams work with a management team also? For instance, do we have to be technical experts in order to carry this out?
No, not at all. So yeah, it just changes the type of project, but we can work with any size company. We've worked with just single entrepreneurs as well. But in any case, whether or not you're a person who doesn't have a technical background, or you've got an engineering team behind you, we can still put together a really good collaboration, I think, because even if say in the case where it's a single entrepreneur, or we're just working with management, then they can bring those ideas about where they want to where say market drivers, or where because they understand the business more, and then we just sort of bring the technical aspects to the idea, to the table, if you like. Don't know if anyone else has got anything to add to that.
I think you summed that up really nicely. I know a lot of the work we do are with feasibility studies for people, and a lot of small SMEs as well. I think we've just hit our hour. Is that right, Mike? You can see the time there?
Yeah, I think we've just about hit the end of the session time that we've been allotted. So I hope we've managed to cover a lot of, if not all of your queries during this session. Many thanks for all your questions.
And I'd just like to thank everybody for joining us today. And don't forget, come and see Hazel and myself in the virtual booth across the 3 days of the Emerging Tech Fest. And thank you. Thank you from all of us. Thank you from the team.
Thank you very much.
Thank you for joining the Emerging Tech Fest. Join us again on our virtual live sessions, or watch us on playback anytime, anywhere.